The next measure of variation is the standard deviation. That's a little more complicated to calculate manually. And moreover, we actually have two different calculations, whether we have a sample and we're calculating a statistic, or we have a population and we're calculating a parameter. Slight difference, but it will give you different values. So a calculator will calculate both of these. And so standard deviation is a measure of how much the values vary from the mean on average. And the way we calculate is we first have to calculate the mean of our values. Then we take each value, subtract from it the mean, divide by n minus 1. So if we have 5 values, we're going to divide by 4. And then we're going to take the square root. Now, for the population parameter, since we have all the values in the population, we're going to divide by the total number of values in the population versus n minus 1. And the reason why we want to divide by n minus 1 for statistic is because they've done lots of empirical evidence that n minus 1 will give you a better estimate. So just because the standard deviation tends to be a skewed distribution, and when we're looking at, experiments, many experiments, using a value of n minus 1 just gives us a better estimate of the true population parameter. So what we're going to do is we're going to look at an example next over here. And here are our steps. So again, dividing by n minus 1 just makes it a better estimator of the population parameter. So here are the steps. Compute the mean for the data set. Compute how far each data value varies from the mean. So that would be the distance from each value to the mean. We're going to square those values. We're going to add up all the squared deviations, and we're going to divide by one less than the sample size. And that actually brings up a small little mistake on the notes over here. Both of those are supposed to be squared before they're added up. So again, we see that summation notation that we saw before. That just means add up all these values. So first, calculate the mean. Find the distance from each value from the mean. Square that distance, add up all the distances, divide by n minus 1, and last you're going to take the square root. So let's look at a quick example. So there are 3 professors on Rate My Professor that teach the Defense Against the Dark Arts class you need. They all have an average rating of 3 with only 5 reviews. So we don't even have to calculate the mean. So our sample mean is equal to 3 for each one of these values. And you can certainly verify that by adding each one of the rating, dividing by the 5 ratings, because each professor has 5 ratings. All right, so the mean is 3. That means when we're taking the value 3 and subtracting 3, that is 0. When we square it, it's still 0. That would be the same thing for each one of these values because all the ratings are 0 for this professor. Now we're going to add up all these values together. We still get 0. We're going to divide it by n minus 1. Remember, n was the number of values, which means that when we're dividing over here, we're going to divide it by 1 less. 0 divided by 4 is still 0. And when we take the square root of that, we end up with the standard deviation of 0. Now this drives down an important point. If there's no variation in our data, our standard deviation is going to be equal to 0 because it's going to show that there's no spread in our data. Let's look at the next data set. There's a little bit of variation within the ratings over here, so this should be a little more interesting. When we subtract 2 minus 3, we end up with -1. Squared, that's +1. Same thing for this. 3 minus 3 is 0, so that's going to give us a 0. Same thing here. And then 5 minus 3 is 2, and 2 squared is 4. So a little more interesting, as I mentioned, when we add these values together, we have 6. 6 divided by n minus 1, just 1 less than our sample size, is 4. This is equal to 3 halved, or 1.5. And then when we take the square root of 1.5, we get a standard deviation of 1.22. So definitely a little more spread in this data set. Last example here, we have 1 minus 3 is negative 2. Negative 2 squared is 4. 2 minus 3 is negative 1. Negative 1 squared is 1. 3 minus 3 is 0. 0 squared is 0. 4 minus 3 is 1 again. 1 squared is 1. 5 minus 3 is 2. And 2 squared is 4. Adding these together, we can see that the sum of these squared differences is a little bit larger again. So that's 10 divided by 4, which is 2.5. Taking the square root of 2.5, we get 1.458. So it looks like the third professor has the most variation because he has a standard deviation of 1.58. Then Professor Moody is next with a standard deviation of 1.22, and Professor Lupin with a standard deviation of 0. So Professor Lupin had all values the same, therefore he has a 0 standard deviation, and Professor Snape had the most, the largest spread in his data, and therefore the largest standard deviation over here. One thing you notice is by the time you square the values, you square those differences, you end up with all positive values. That just makes sure that the positive and the negative values don't cancel each other out, in which case, you know, if we have a symmetric distribution, we would end up with very little spread. So it's important that the values are squared before we add them together. As you can see, it's a lot of work to calculate the standard deviation of a data set. In our example, we only had 5 values. We had the mean given, and that wasn't that much work. But in general, when we have large data sets, we're simply going to use our technology to calculate the standard deviation for us. One last thing over here is the variance, which is the average of the squared difference from the mean. It is just the standard deviation squared. So basically what we would do is over here, we would not take the square root in the last step. So our variance for Professor Lupin is still 0. Our variance for Professor Moody is 1.5. And our variance for Professor Snape is 2.5. Now there's some advantages of using the standard deviation versus the variance. And in general, what's nice about the standard deviation and the reason why it's often used is that we first square the values, but then we take the square root at the end. So that ensures that we actually use the same units. So if our measurements are heights in centimeters, then our standard deviation is also in centimeter. Variance, on the other hand, we don't take the square root at the end. So therefore, our variance would be in centimeters squared instead of in centimeters. So big distinction over there. The advantage of the variance is that it's actually, our sample variance is a better estimate of the population variance. We call it an unbiased estimator. So it actually targets our population variance, where our standard deviation is a slightly biased estimator. The bias is fairly small, so it's often used in real life and in industry and in statisticians all around the world use it. However, you need to be aware that there is a slight bias. We try to reduce the bias by dividing by n minus 1.